All right, so we're going to take our data from the falling ball and we're going to try to make a graph. So we said the first data point started at 0 seconds, 0 0.3, 0 0.5, 0 0.8, 1.0, and 1.2. And then, so that was our time axis. And we can actually change this if we want from X to T, okay? And our Y direction as well is vertical. Okay, so in physics, we're going to use Y to represent the vertical direction. So we could say 0, 0.1 based off our data table we have up there, 0.2, 0.45, 0.7, and 1.0. Okay. Now, all of these values were in what direction? Were they up or down? Down, so they should all be negative. So our graph should actually face the other direction. So we can just go back in there and add our negatives in, okay? All right, what should we do next?
Just the domain and range.
Just the domain and range. So the x-axis is time measured in seconds. Our domain went from 0 to 1.2 seconds, so I'm gonna go from 0 to 1.5. Or we can even make it a little bit negative, so we can say negative 0.1 to 1.5. Our y-axis is position. Is there an I there? I'm gonna misspell this. Oh man. Yeah. Okay. Position in meters. Okay. And we could even say it's a vertical position in meters. And we started at 0 and we went to -1. So we'll go from 0 to -1.1. And that probably should give us a good answer. Oops. -1.1 to 0 would make more sense. Okay, so we have our graph, and we could tell from our graph, we'll call this 0.1 to give us an axis there. We can tell from our graph that it's quadratic. Okay, so remember, if we want to fit our line, we can just add it in to the next line. So in the next line, we're looking at the y1 value that's out of the table. If you just put y in there, it won't work. Okay, in the table it was y1. You could have multiple rows in your table, so you could keep adding y2, y3, y4, those sorts of things. We're going to use the tilde symbol. We want an a t1 squared plus b t1 plus c, and that gives us a fit of the data. Okay, so that gives us an equation that fits the data, where our a value is 0.629, our b value is -0.6, and our c value is 0.007. Okay, now we know a couple of these values, to be perfectly honest. Okay, and as we get through looking at some of the data, our b value in this case represents initial velocity. So if we're dropping the ball, what would the initial velocity be? 0. And our c value represents the initial position. So if we dropped it from the origin, our initial position would be 0. So a better fit to this curve, since we know that it started at 0 and 0, would be without this data. So we actually might get a more accurate diagram if we went this route.
Shouldn't you start the graph at however high you drop the ball from, and then you the 0 would be where it would be down?
Well, we were measuring it in a negative way because we noticed on the board our origin is at the top.
Oh, okay.
But we could put the origin on the bottom and start at 1 and go the other way. Yeah. All right, so if I wanted to use this graph, remember, I could then export the graph as an image. Personally, I like the rectangular graphs. I think they're better looking. I like the thin line graphs. The thick ones look like you're in elementary school, but you know, to each his own. So then you could download it and you have a nice image you can then import to your lab report. Okay. Questions about this?